All right, so we're going to just continue looking at proof by induction. We're going to apply it now to a little bit of our um, number sequences that you've been doing in methods. So we've got this number sequence. The first term is 11, and we're told an iterative way of doing it. We're told that if you know any one term, then you can times it by 10 minus 9, and they'll give you the next term. And we want to prove that you can get any term through the system rather than having to go through this iteration. So what we're going to do is the same as before. Check for 1. So first step, check for n equals 1. So if we look here, I've got t1 will equal 10 to the 1, which is 10, plus 1, which equals 11, which is indeed what we've got for term 1. So that's a good start. So step 2 is assume for n equals k. So we've got tk equals 10 to the k plus 1. Now we want to look at n equals k plus 1. Now here we're looking for t to the k plus 1. Well, using this here, I can say something about that in the terms of the previous term, which is this tk. So it's going to be 10 lots of tk minus 9. Now I've assumed that tk equals this, so I can now substitute that in. I can say this is going to be 10 lots of, open brackets, 10 to the k plus 1 minus 9. So this is all looking at my left-hand side. And then multiplying this through, I get 10 times 10 to the k plus 10 minus 9. 10 times, I can put a 1 there, and I could add my power, so I can say that's k plus 1. And then 10 minus 9 is plus 1. Hey, look, that's exactly what I should get if I put it into my right-hand side. So I've proved it by induction. Notice that sometimes we talk about more complicated sequences. For instance, the Fibonacci sequence, the next term relates to the previous two. You can actually extend this to look at that. If you're extending it, if you're looking at that Fibonacci sequence, which is Tn equals Tn minus 1 plus Tn minus 2, or however you want to express it, maybe Tn plus 1 equals Tn plus minus 1. You'd have to check the first two terms. You came up with some kind of rule. Because you need these two terms previously to then go on to do the next one, and then you assume it for for two terms, and then show it works for a third term, and that will still get you the whole logic of induction. It just you have to do a little bit more work.